To start recording. Okay. Okay, let's record from here only. Uh, I will just repeat a couple of questions for the sake of recording because the recording didn't start. Okay. So just bear with me. Okay. So welcome to week 10 assignment 10 TS session for Introduction to Robotics. I am your TS Suraj Borate from IIT Gandhinagar, PhD student, and this assignment has been repeated this year, so I won't be solving it completely, but I will give you some hints and how to think about this assignment, so that will be useful. How to think about the questions. Okay, and I will discuss some of the theory. So the first question says that which of the following algorithms make the Markov assumptions about the system dynamics, and some options are given. And what does Markov assumption means? Markov assumption means that the current state depends only on the previous states and the input provided at the previous state. Okay, so the history, entire trajectory history does not need to be remembered. So if you just go through all the algorithms and see which of the algorithms are of this form, xt is equal to f of xt minus 1, and then you will be able to answer this question. Okay, second question that we have already discussed before I remembered that recording hadn't started is the second question. The Kalman filter updates results in a Gaussian belief distribution, and this is how the Gaussian belief looks like. Okay, so this is the variance and this is the mu, and you just have to check whether this is true. Look at the measurement noise model and look at the motion uncertainty model, and whether such kind of stuff is present there. The reason says that the Kalman filter assumes an exponential motion model. So exponential term is a non-linear term, right? So whether the Kalman filter is working for non-linear, you have to check that. Okay, I will not tell the answer. Third question is assume that the robot is moving in a circular trajectory. Okay, so robot is moving in a circular trajectory means what? So they have told that robot is capable of moving circular trajectory, right? That means your robot will have certain dynamics in its equations, right? Certain terms in the equations. Okay, the equation might look linear or non-linear. Okay, and depending on that you have to answer this question. Okay, see the properties of Kalman extended Kalman particle and all. Some of the filters may not require model at all. Some of the filters may require linear or non-linear model, or some of the filters might work for both. So choose accordingly. Okay, now I have done a quick recap for benefit of the viewers who are not present, and so let's move on to the question that we were discussing. Okay, so assume the following dynamics for one dimensional system. So my question to the learners was, can you tell me whether these equations are linear or non-linear? Hello, can you hear me? It's a very simple question. Xt is equal to xt minus 1 plus ut plus epsilon. Is this equation linear equation or non-linear equation? Hello, are you there? Oh, I have lost the connection. Hello.
Yes, sir. You dropped for a while.
Yeah, actually the net connection is a little bit this, so please bear with me. Okay, let me just reconnect.
Right.
Wide board का option ही नहीं आ रहा Okay, can you see my screen? Hello, can you hear me? Hello, can you hear me? Hello, can you hear me? Hello, hello, can you hear me?
Yes, sir. You're audible.
Okay, so for
We can hear
bandwidth
you,
Yes,
sir.
sir.
issues, I will just keep off my video. Okay, so let's continue. Okay, let me just check if the recording is going fine. Okay, okay, I will deal with it later. If something goes wrong, I'll re-record. Okay, so my
Sir,
question to you
one
was,
request. If you could just solve this numerical with imaginary values to give us an understanding of how it will be solved.
okay, we can do that. We can do that. Okay, but yeah, to how it can we can solve, I can tell you. That is not a problem. Okay, and it's just value substitution only.
Right.
So yeah, I will just show you how we are going to solve this. I will not put any values
Right.
imaginary because then I don't have the right answer to check and all. And but I will show you the steps
Yes.
completely.
Yes. That is
Yeah.
fine.
So okay. So first of all, my
Yes.
question
That will be sufficient.
was that xt is equal to xt minus one plus ut plus epsilon zt is equal to xt plus eta is a linear equation. Okay. So this is how linear equation looks like. Okay.
Right.
And on such equations we can use Kalman filter. Okay. And that is something that can help you somewhere else. Okay. Now they have told that the Gaussian random variables are sigma, epsilon and eta are zero mean. Point 1 is the variance. Given the initial belief is a Gaussian zero mean and unit variance. U1 is point 0.1 and Z1. What is U1? U1 is the input. Z1 is the measurement at step 1. Okay. So you have zero mean, point 0.1 variance. Okay. And you have u1 is equal to point 0.1 and z1 is equal to 0.11. Okay, so what you have to do is basically you have to, which of the following is the closest to the new belief step. So you have to do only one iteration of Kalman filter. Okay, so what was Kalman filter we will revise. Okay, so this is what you have to do. This is the entire procedure. Okay, hello, can you hear me? Hello.
We can hear you, sir. But if you wrote something on the
Yeah,
board,
I will write. Okay,
if you
just
written something on the board, it has not.
no, I haven't written. You can see Kalman filter.
Right. But we can.
I have not written anything right now. Okay, you can see Kalman filter, right?
Yes. Yes.
Okay, okay. So what we have is here. You have been given mu t minus one value. Okay, right? Zero mean, right? You have been given the variance, whatever is given in the question. You have been given ut value, the input ut, and you have been given zt value. Z1, u1 you have been given, variance you have been given, right? And you have been given mu. Agreed, everyone? So, and you have been given 80.
Yes.
What is the value of 80? I will not tell, okay? From the question you have to tell. I will just show you the question again. 80 bt, you tell me what is that? Okay. The other values you can see. You have been given sigma, okay? That you have been given. Okay, ct also you have been given. That also from equation you can see. Okay. And what is rt? That you have to tell me. Rt, sigma t, these things you have to tell me. Okay. I will just show you the question again. Okay. So here is the question. Now you tell me what is the value of
So your
ut.
screen is not so your screen is not updating, sir. We are unable to see anything new. It is still
Okay.
showing that assume the following dynamics. It's stuck on that screen, sir.
Acha, it is stuck on that screen. Okay, let me check what is going wrong. Wait. You can see now this, na? Whatever. This you are able to see. Hello? Now you can see. Hello? Can you see me? Can you see the screen? Sorry. Hello?
Yes, yes. Now your
Yeah.
screen share is updated.
Yeah. So what I was telling was mu t minus 1 is given, sigma t minus 1 is given, ut is given, zt is given in the question. Okay. And also at, bt and ct are given. Fine. So
Okay.
if you see the question, na, they have given some model. Okay. So there is some model given over here. See, I will show you the question. It is given na xt minus 1 plus ut. So what is usually it is a into xt minus 1 plus b into ut, right? Right. Hello. Can you understand?
Yes.
Yeah.
Yes,
So
yes.
that means at is 1, bt is
Yes,
1.
sir, I can understand.
That is the hint I am giving. Okay. Similarly, you understand the what
Okay.
will be
Got
ct,
it.
what will be how to find rt, how to find qt. So when you relate to that, you will understand. Similarly, they have given ut and they have given zt that they gave here. Ut is 0.1, z1 is 0.11. Now you just have to substitute the values into the algorithm, nothing else. Okay, you substitute into this algorithm, go on following.
So,
Okay, and you will get the value of mu t and sigma t. Okay, once you get that you check over here. Mu t will be mean and sigma t will be variance. Fine.
okay, so typically how we solve an algebra, that is the approach we'll take, sir.
Algebra is nothing. Algebra is just
Like if there is no
80.
value.
Values are given. There is no algebra. Just you have to substitute. You have to don't solve. You don't have to solve equations here. Okay. Just substitute the value. First you will get mu t bar,
Okay. Okay.
and you will get sigma t bar. Use that sigma t bar and mu t bar to find kt and mu t. Then you use kt and this thing to find sigma t. Just if you go on following the steps in the line, okay, you will get the answer. Fine. And
So
this
we
is
follow this exact steps, the Kalman filter
yeah,
algorithm.
yeah. Just follow
Full
the
we
exact
go
step.
by
The
this only.
only thing where you can go wrong is identifying the values. What
Mhm.
is the value of AT? What is BT? What is CT? What is QT? What is RT? Identify what is what. That only you have
Okay.
to see. Do nothing else. Okay. Fine. I will go on to the
Okay.
next question.
Okay.
I cannot give more hint here. Okay. So
Yeah. Yeah.
So the next question says that the importance weight used in particle filter accounts for the observation probabilities. Okay, so if you remember the particle filter, okay, let me just open the particle filter. Okay, let's see the second statement also. Importance weight used in a particle filter accounts for the noise in the state transition model. Okay, so what the basically it says what is importance weight used for. That's it. That is the question. There is an entire section on where Sir discusses about the particle filter. It's about 10-15 minutes. If you are 10 to 20 minutes, you can just go through it. Yes, explain very clearly. Okay, and he also gave a very intuitive example. But we will also go through the algorithm. Okay, then you can maybe answer this question by yourself, and I will also go on to the sixth question. We'll just read the question before we go on to the particle filter, understanding particle filter. So particle filter deprivation can be mitigated by which of the following? Okay, so there is some problem. So there is also something called as some section where he has discussed the limitations of particle filter. Okay, if you refer to that section, the slides, you will be able to answer question number 6, where he discusses the word particle deprivation phenomenon. Okay, so basically it means that the number of particles, okay, their value starts reducing. Okay, so they start converging and their value starts reducing. So let's look at the particle filter. Okay, both if you I will just discuss particle filter, not the answer to these questions. So you can see the algorithm for particle filter, or
Understood, sir.
yeah, you can see the okay. So particle filter, very much like what we are discussing Bayes filter, it takes the previous state belief xt minus 1. So it is not exactly belief. Sir also discusses this point, but it is some kind of probability about the previous state. Okay, what it understands by the previous state. Then it takes the previous input and previous measurement zt. Fine. So is it following the Markov model? That is something you have to think about. Okay, because that is one of the questions. Okay, so because see t minus 1 is coming, right? Okay, so now what they are saying is, for m equal to 1 to capital M, that is the number of particles. Okay, you will sample xt, a particle xt, from this probability distribution. Okay, so it works for non-Gaussian probability distributions too. Okay, so P can be any probability distribution. You sample from P using one particle xt minus 1. Okay, so you have just created one particle, sample a particle from probability distribution. Similarly, what you do is you take the sensor model P of zt, given xt m. You take the sensor model. What sensor model tells you is that, given the sample xt to m, what is the probability of that particular measurement? Okay, so given the state, what is the probability of that measurement, such measurement that will happen? So you have done the measurement. Okay, so that is zt, you have the measurement. Okay, so this is the this probability is nothing but wt, and this wt is nothing but the importance of xtm. right? See, suppose, okay, think like this. Suppose XTM is a particle that is less likely, okay, then it will not correlate well with the measurement ZT. Okay, so WT will be lower for such particle. Okay, the probability that ZT given XTM will be lower. So that is why it is called importance, right? And then what we do, we will update the belief using both the importance and the state. Okay, fine. And then what we do, we again will resample the particles among the current particles based on which particles have high importance. Okay, so we draw I from probability directly proportional to the importance. Okay, suppose the so we are again drawing m particles. So see, if you see line number 3 to 6, there we created some number of particles based on the probability distribution and the sensor model. Okay, and we also created some weights. We had a list of particles. What are particles? Possible positions, let's say possible position xt's, and we have list of weights. Okay, you are able to hear me, right?
Yes, you're audible.
Yeah,
You're
yeah,
following
yeah.
up.
Okay, so there is a list of particles, that is nothing but list of states. Or for now, let's assume there is only one state position. Okay, so there are list of positions, m positions. Okay, according to the probability distribution. Okay, now for each of these positions, we have calculated a corresponding weight, WT. Okay, so the size of the list where the weights are there is same as the size of the position list, right? And there is one to one correspondence. Okay, you imagine like that. Now, for the weight, okay, what we will say is, using this weight, we would just want to keep those positions which are important, and that is why we calculated weight. And what tells us whether a position is important or not? The measurement, right? So the weights, importance weight, that is WT, is calculated using measurement ZT. Okay, and once we calculate the importance weight, and we have a list of important weight, then what we do is, during the resampling step, okay, during the resampling step, we will again get m particles. We will choose m particles among the earlier m particles. So some particles will be repeated. Okay, why? Because we are drawing particles according to their probability or according to the importance. Okay, suppose the particles which has more importance will be repeatedly pulled out when we are sampling. Okay, because it is pulled out according to the uh, its importance or the probability. Okay, its probability, because it has higher probability of pulling out. Okay, and then we add to a new list called xt. Okay, so initial list is xt bar, and the second list after resampling step. So 8 to 10 is resampling step. Resampling. Okay, this is resampling step. Okay, and here we are using the importance weight. Now, okay, now you understood why importance weight is used. Where it is used to resample. Okay, now that will help you solve the question. And also, there is this question on limitations of particle filter, where particle deprivation term was used, that you should search in the limitation section. So that covers all the questions. Okay, and I think this session will help you for solving this assignment very directly, because the questions are same. Okay, I have tried to be as useful as possible without giving the answer. Okay, so apart from this, do you have any doubts or something you can ask? Okay.
So,
Okay.
are these typically the type of question that can come in final exams, or any further topics can be added onto it, like
So
the type of
actually,
question that we are solving
so
in
I have
assignment.
never seen an NPTL final exam, to be very honest. Okay, but I think if the assignments are being
Okay.
done like this, so do you know whether the final exam is subjective or objective or something like that? Hello,
No, in my
you don't have
previous
any idea
attempt,
because
in
there
my
are some.
previous attempt,
Yeah. Hmm.
when my previous attempt, I gave a very tougher course on robotics. So that was a very much more advanced version
Okay.
than this one. This is a more introductory level.
Yeah,
But
yeah.
I'm assuming like in that exam there were like certain concepts which did not were not covered in lectures, but in final exam some how can I say tricks or some very tough
Yeah,
questions
yeah.
came along.
And the
So I'm
assignments,
assuming that will not happen in
assignments
this one,
and
and
the
I'll
final
get
exam was also
normal.
similar or not? So the assignments were not similar to final exam. That's what you are saying,
Right.
huh?
So
Okay. So you see, in
yes, yes.
that
But
case,
I'm assuming since this is a very
yeah. So your assumptions, I cannot, confirm. That is my problem. But what I can tell you is that if you understand the concept well, then hopefully you can do well in the final exam. Uh, if you have questions, if
right.
you feel that you have you want to discuss something else apart from the questions that we are discussing, then what we can do is you can
Mhm.
bring up that question and we can try to look at it or something like that. Okay, but I think what is discussed
Okay.
in the class, okay, final exam will cover that only. I don't think they will cover anything else apart from what is discussed in the class. Maybe what is discussed in assignment, or that may be relevant or
Mhm.
irrelevant, but what is discussed in the what professor discuss in class, you should expect irrespective of whether it has been asked in the assignment. Okay, if he has made a statement it didn't
Right.
appear in the assignment, then we cannot give any excuse. Or and also this is NPTL, right? This is
Right.
about self learning. Okay, so we can help you to a certain extent, but if some question is coming off, then it has, maybe it is because maybe they are expecting you to think or do some self study or something like that. But I don't know, I have never seen looked at the exam question paper. Okay, you have the experience more than me in that, so prepare accordingly.
Got it, sir.
Yeah,
Thank you.
if you need any
Sir,
help
I
from me,
have
you can tell. Yeah. Yes, you are asking something.
yes,
Hmm.
sir. Previous week means week number 9
Okay.
assignment. I have one doubt, sir. Uh,
Okay. Yeah,
sir,
what is
in
the
that
doubt?
week number 9,
Hmm.
sir, in that we have question saying which of the following are valid state variables for a
Okay.
Markov model.
Fine.
Uh, so it's a multiple correct answer question.
Yeah,
So
yeah,
in
yeah.
that,
So I will pull up
is
that.
the stoplight
Hmm?
can you please help me why this is the stoplight red is also correct answer? I thought the previous ones, if there is a sims or something in them, then it is considered as a Marco.
Can you repeat your statement?
So I got
Is the
means I is the stoplight red?
hmm.
Is
Yeah, what you thought? Yeah, I am asking what was your thinking that you repeat.
So I thought if we have any previous state mentioned, then only it is a valid state variable for Marco. I like sims from if there are there such statements, then
Yeah.
those comes under Marco model.
Yeah, yeah. I will just open that
Uh,
question. So when I discussed this question last time, na, actually no one attended the last session.
sir,
But yeah, so at that time I had said that this is a bit subjective question. Okay. So when I was also giving the answer for
sir,
the question, I was also a little bit confused. But I will just try to tell you. Okay. I will just open up that question. Yeah, so if you see, is the stoplight red? Okay, which of the following are the state variables for Markov
Sir, I'm
model?
dropping off. Sir, I'm dropping off.
Okay, okay, fine. Whoever wants to leave, you can leave. Okay, I
Thank you,
will
sir.
answer the question. Yeah. So, which of the following are valid state variables? So, see, when we are saying Markov model, na, it means that you depend only on the previous state. Okay, that's it. Not before
Yes, sir.
that. Now, is the spotlight red? Depends on what? The current state only, right?
Yes,
That,
yes, sir.
yeah, and you thought that previous
It's
state
a
is not
question
there.
important.
Yeah, so your thinking was in the right
Uh,
direction, but the thing is, it is even better than Markov model. Okay, so there is no problem. It is a Markov state. Why? Because see what happens is, okay, you can think this in two ways. One thing there, if you are thinking that it only depends on current state, okay, then it is not depending on the history. So it is still the Markov model. Okay, so Markov says that it should not depend on history like all the previous states. So it is still Markov model. Second way you can think like this. Okay, there is red, green, and yellow, right?
yes, sir.
Huh. So is that your signal being yellow in the previous step enough to tell you that your current state is red?
No, sir.
Hmm?
Means yellow is there, then green might come. I said.
Green might come after yellow, like that. Okay. So after green, can yellow come? No.
Uh,
Right? After green,
yes,
what can come? Red only, na?
red, red.
So
Yes,
only
sir.
your previous state is enough, right? ग्रीन के बाद
Yes,
येलो
sir.
तो नहीं आएगा. बराबर. खाली अगर
हाँ,
आपको पता है ग्रीन है, तो रेड ही आ सकता है.
हाँ, सर.
हाँ. तो सो
So,
इट डिपेंड्स ऑन द प्रीवियस स्टेट. तो वैसा भी आप सोच सकते हो. तो दैट्स व्हाट आई टोल्ड दिस इज लिटिल बिट अ kind of subjective question. You have to think creatively to answer this, and maybe you might have thought in some other way, so you can get a wrong answer or something. For example, the onboard battery level since last recharge action, I was thinking it is a Markov. Okay.
I also mentioned that only, sir.
Yeah, I
Since is
also,
there.
yeah. So I was thinking it is Markov, but it is not Markov. Why it is not Markov? Maybe they have thought in certain perspective. Maybe they thought that okay, the current battery level depends only on the current battery level. Okay, previous battery level doesn't matter. But I don't know. Okay, so this is little bit tricky, the C option. But your option was is the stoplight rate, and I have answered that. Okay.
Yes, sir. Yes, sir. Sir,
Yeah.
one question related to like initial weeks is if number of joints, can I say that number of joints are always equal to number of degrees of freedom? Can we say this way, sir?
Number of joints always equal to number of degree of freedom. Okay, that is your question.
Yes,
So
sir.
I will say, let me think about this. This is a little bit tricky question. Hmm. So I won't say yes. Okay. So not always, not always. Okay. Sometimes see it depends on how what you are thinking about degrees of freedom. Okay. Suppose you are just think. So in manipulators, na, robotic manipulators, when we talk like that only. Number of joints equal to number of degree of freedom. So for example, if you take a 2 hour manipulator, this has 2 degrees of freedom. Okay. If you see there is a three
Yes,
hour
sir.
manipulator, it has 3 degrees of freedom. Okay. But if you take 4 hour manipulator, how many degrees of freedom it has?
Uh-huh.
It has again 3 degrees of freedom only. Okay. It has four actuators. Okay, it has four actuators,
Yes, sir.
but the degrees of freedom is four. How? Because the end effector, okay, x, y, and theta, orientation. Only three variables can define because it can move only in a plane. Okay, so the
Small
degree of
breaks
freedom for
in
the
your
end
voice, sir.
effector is,
Sorry, I am not.
you are not able to understand. Okay, so what is the position of the end effector? X comma y. And what is the orientation of the end effector? The line like this. Okay, with respect to x axis is the theta. Okay, so the end effector will move in the plane
So
only. Na?
actually,
Any number of joints if you put.
so voice.
Yes. Hello. You can hear my voice.
Actually, there is small like stuck in your voice, sir.
Now you can
I
hear.
think there is a
Hello.
network.
Can you hear me now?
Yes, sir. Now you are audible, sir. Yes, sir.
Okay. Okay. So little bit I am out. So that's why maybe. Okay. So you can see that if I
Okay,
am
sir.
drawing a 4 degree of freedom manipulator here.
Actually, your screen is that one is not visible, sir. I think the only assignment 9 screen is visible,
Acha.
sir.
But I am drawing na manipulator assignment 9. Can you see that? You cannot see the
I think
drawing.
I will once rejoin, sir. I will.
Okay.
Then
I
I
will just.
no, sir. I am not. I will just rejoin one, sir, so that I think maybe it's not refresh from my page. I guess.
No,
One
you
sec.
don't rejoin. I will just stop the present screen and क्या पता इसका क्या डिग्री ऑफ फ्रीडम नंबर जॉइंट सेम नहीं रहता है हमेशा. Can you hear me? Hello. Hello. Can you hear me?
Yes, sir. Yes, sir. You're audible, sir.
Okay.
Yes, sir.
Can you see the screen? No, na. I will just see,
No,
start
sir.
this.
No.
Now you can see the screen, na? Can you see the screen? Hello. Can you see the screen?
Uh, yes, it's showing it's presenting, sir. Maybe it would take some
Okay,
time,
okay.
I guess.
Now you
Like
can see
one,
the
two.
screen. Okay, the screen is
Uh,
not important. I will just turn off
yes, sir. Yes, sir.
this thing. I will just explain you verbally. Okay.
Yes, sir.
So yeah, I will.
Yes, sir.
So
Yes.
you do before I answer this, you don't have any further questions, or you have any further questions, so that I can discuss the
No, sir.
this.
Actually,
Hello.
I am actually. Yes, sir. Am I audible, sir?
Yes, yes. Say.
Hello.
Yeah, yeah.
I am actually resolving assignment questions
Okay.
initial week, sir. So in
Okay, I
that
will
one
try
of
to
our
answer.
assignment, I
Yeah, 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 I will answer your question. Wait, just let me disconnect the writing pad so that the disturbance is not there. Okay,
okay,
fine.
sir.
Yeah. So your question was that the whether the number of degrees of freedom and the number of
Hmm.
joints can be different or not. So answer is different. It can be different. Okay. So the
Acha.
robots which has number of degrees of freedom less than the number of joints or the number of actuators are called under actuator robots. Okay, sorry, are called over actuator
Okay, sir.
robots, and the robots where the number of actuators are less, okay, than the number of degrees of freedom
Yes, sir.
are called under actuator robots. So if you search for under actuator and over actuator robots, you will understand. Okay. One more statement I want to make here is, if you see a quadruped, sorry, quadcopter. You know quadcopter, right?
Sir. Yes, sir. Yes, sir. Drone.
Drone. So drone
Yes.
में four
हाँ,
actuators are there. Four actuators, right?
हाँ, sir. Yes,
But
sir.
degrees of freedom कितना होता है?
अच्छा, three, sir.
Six. Six. Roll pitch yaw
अच्छा, पीछे है
and
तो
x y z.
रो
हाँ. तो
अच्छा,
डिग्रीज
अच्छा.
ऑफ फ्रीडम और नंबर ऑफ एक्चुएटर अलग हो गया ना, राइट?
Uh-huh. Yes, sir.
Similarly, if you see a 2R robot, 2R planar robot, हाँ,
Acha,
उस
yes, sir.
उसमें दो डिग्रीज ऑफ फ्रीडम है, एक्स एंड वाई ऑफ एंड डिफेक्टर. Okay,
Yes, sir.
end effector can be defined by x and y, and there are two angles. So number of degrees of freedom equal to number of joints. 3R रोबोट में क्या होता है? 3R रोबोट में
Uh, Rotate in its own axis also.
हाँ,
Apart from that,
नहीं मतलब 3R
we have
रोबोट, 3R planar robot, there are three joints and 3 degrees of freedom x y and orientation. Okay, orientation of end effector. But if you
acha,
continue on putting some r, okay, continuously, ठीक है,
sir.
then what will happen is जितना degrees of freedom हो सकता है उससे ज़्यादा
अच्छा
उसका joints हो जाएगा. Okay, but
सर वो
but
जो राइनो एक्सआर 3 रोबोट होते हैं तो दैट इज हैविंग मोर डिग्रीज ऑफ फ्रीडम देन नंबर ऑफ जॉइंट्स है सर ये जो
नहीं
राइनो
नहीं,
एक्सआर 3 रोबोट.
Rhino XR3 robot. I don't remember how that looks. Okay,
अच्छा अच्छा.
but yeah, but I
ओके
think what you can see, if you make a very long snake robot, just join डालते गए डालते गए डालते गए डालते गए, है ना, लंबा बनाते
लाइक
गए उसको.
फ्लेक्सिबल रोबोट्स ऐसे हाँ
हाँ,
सर स्नेक
फ्लेक्सिबल रोबोट
की
होता है.
तरह.
हाँ, तो उसमें क्या होता है कि उसको
सर
उसको हाइप उसको रिडंडेंट मैनिपुलेटर बोलते हैं, क्योंकि उसमें नंबर ऑफ एक्चुएटर्स ज़्यादा रहता है. ठीक है,
सर
बहुत ज़्यादा रहता है
सर
जितना ज़रूरत है उससे.
हाँ अच्छा
So,
अच्छा.
sorry, not redundant.
सो वी कांट.
So, it is not necessary that the number of degree freedom equal to number of joints. But
वी शुड
what
नॉट.
I would suggest is, if you are asked that what is the number of degrees of freedom, is it equal to number of joint? Question आया, okay. And look at the
हाँ सर
options.
हाँ
If they
सर
are not talking about under actuated system, if they are not talking about over actuated, hyper redundant, ये options में नहीं है,
सर
तो आप ट्रू करो.
सर.
क्योंकि क्या होता है कि for basic robotics introduction to robotics course, we say that okay, number of degrees of freedom equal to number of joint.
अच्छा
Yeah, so that
अच्छा.
way it is defined also. Lot of time also
ओके
for snake robot also we interchangeably say okay, these are number of degrees of freedom, because that is the point of view. If you see configuration space point of view, then it is actually number of degrees of freedom. So
अच्छा.
that we will discuss in next time, configuration space from through
ओके
a motion planning perspective. But there is no,
ओके.
this is little bit tricky question. Okay,
अच्छा सर.
yeah, any other
ओके सर
question?
ओके. No, no, sir. Only this. I am confused sometimes. Key joint where like number of joints will always be number of degrees of freedom
No, no, no.
in
So
any
degrees of
manipulator
freedom is
like
a
that. I
much
thought,
more
sir.
general term. For a
Okay, sir.
rigid body there can be maximum 6 degrees of freedom. For a robot you can have
Sir,
lot of degrees of freedom, but depends on some joints. अगर दो joint को एक ही axis में लगा दिया parallel, okay,
sir.
so then both joints are useless na, only one of the joint is useful. So you can have only
Yes, sir.
one, so such in singular configuration. So in that case it is not equal, so it also depends on number of robot. So
Sure. Okay,
so
sir.
yeah,
Okay, sir. Only this part
okay,
I
thank
got.
you.
Okay, sir. Fine, sir.
Okay,
Thank you,
bye.
sir. Thank you.
Hmm.
Bye, sir. Thank you.